Hello, my name is Nidhi and I'm from team number 6. My teammates are Muzammil, Rashmi and Mahesh, and we are working under the guidance of Professor Preeti Pillai. So the title of our project is Number Plate Detection and Recognition. Let's move towards the content. So our presentation includes introduction, literature survey, need statement, problem statement, functional block diagram, data sets, algorithm, results and references. So firstly, let's move towards the introduction. So what is number plate detection? An automatic number plate recognition is a technology that uses optical character recognition on images to read the vehicle registration numbers in order to create the vehicle location data. So what is a number plate? It basically is a metal plate that is attached to the vehicle and has an official registration number of the vehicle embossed on it. So it can use the existing closed circuit television, that is the CCTV, or the road enforcement cameras, or the cameras specifically designed for the task. So in order to get more depth knowledge about this topic, we went on studying a few research papers. Out of them, the title of the first research paper is A Novel Method for Indian Vehicle Registration Number Plate Detection and Recognition Using the Image Processing Techniques. So this paper has proposed and implemented a methodology to detect the number plate of a vehicle, of an autonomous vehicle. So the proposed methodology, it consists of three major phases, that is pre-processing, detection and recognition. So it basically used the algorithm called as KNN, that is K nearest neighbors algorithm, which works by classifying the data points and fitting them into the nearest group. So it was successful in detecting and recognizing the number plate. The title of the second paper is Continuous Detection Based Vehicle Plate Recognition. So this paper implemented a methodology to detect the number plate and also to recognize it. It followed these various steps. So first is read the input image, convert it into grayscale, find the edges, filter the image and separate the image into objects, and then recognize the number plate by applying the continuous detection method. Similarly, the title of the third research paper is Automatic License Plate Recognition System Using Web Technologies and Image Processing for Real-Time Retrieval of the Information. So this paper consisted of three major phases, or three major steps we can call it, that is localization techniques, vision API and segmentation across the detected image. So this paper was successful in detecting and recognizing the number plate of a vehicle. The next title of the paper is Smart Vehicle Number Plate Detection System for Different Countries Using an Improved Segmentation Technology. So this paper basically used an algorithm called as the Sobel algorithm that extracts the objects in the image that has sudden change of intensity of the pixels in the images. So these papers did face a few challenges, but they did overcome these challenges and detected the number plate and also recognized it. Then let's move towards the need statement. So the main objective of number plate detection and recognition is the effective enforcement of the traffic rules, which improves the analysis of the city's traffic during the peak period. So we also know that the increasing number of ECUs leads to the threat associated with the vehicles. So in order to provide the improved security for both car park operators and car park users, vehicle number plate detection aims at detection of the license plate present on the vehicle and then extracting the contents of the number plate so that we can easily detect it and then recognize it. This is the project management Gantt chart, which explains us the tasks that were involved in this project. So we started our project in the month of August, and the tasks were survey, initiation, analysis, planning, design, implementation, and closure. So after performing all these tasks, our project ended in the month of December. Next, moving towards the dataset. So we collected our dataset from the website called as Kaggle, and here are the details or the descriptions of the dataset. So the input image size is 554 cross 554 pixels, and we collected a total of 450 images. So the next is the problem statement. So after studying about all the image processing techniques and about the details of the now how the number plate detection and recognition works, we came up with a problem statement, that is, design and develop an algorithm for the number plate detection and recognition system in the vehicles using image processing techniques. So now let's move towards the functional block diagram. So in the functional block diagram, the first block is an image source. We take the input image source and then we convert the input image source from RGB to gray. So after converting the RGB image to gray image, next step is the pre-processing step. After pre-processing step, we detect the edges. That is, we are detecting the edges from an edge detector called as scanning edge detection. So after detecting the edges, we apply contours in order to get our region of interest. So once we get our region of interest, then we detect the number plate, and then later on we recognize using the OCR technique. Similarly, this is what the algorithm is. That is, we take our input image, we convert it from binary image to gray image. So as less information must be provided to the each pixel, then the gray image is converted into blur image using a filter called as bilateral filter. Next, the next step is detection of the edges using the scanning edge detector and applying contours all over the image, then reducing the number of contours so as to process the region of interest. Later on, the final step is the number plate is detected and displayed, and it is recognized using the optical character recognition. Next, let's move towards the need for optimization. So what is optimization? The optimization reduces the cost or increases the output efficiency. It reduces the execution time and the memory that is required. The optimization techniques that we use in our project are loop optimization. So it basically is the process of increasing the execution speed and reducing the overheads associated with the loop, and decreasing the number of instructions in an inner loop improves the running time of the program even if the amount of the code outside the loop is increased. So, and we also ensured that the memory utilization is minimum in the code. So the code was written in such a way that the memory utilization is minimum. Now let's move towards the theory. So in order to detect the edges, we used an edge detector called as scanning edge detector, and this is how it works. So the first step is using the bilateral filter. So a bilateral filter is an edge-preserving, noise-reducing smoothing filter that is used for images. So it smoothens the input image by applying the bilateral filter for edge preservation and noise reduction. So it ensures that only the pixels with the intensity values similar to that of the central pixel are considered for blurring, and the rest sharp intensity changes are maintained. The next step is calculating the intensity gradient. So it identifies the areas in the image with the strongest intensity gradient by using the toggle operator. So it consists of two kernels, one is x-directional kernel and a y-directional kernel. So upon applying the convolution, we get the direction of the gradient and the magnitude. The direction of the magnitude are calculated using the formulas that is mentioned. That is, magnitude is square root of the x gradient plus square of y gradient, and the direction of the gradient is calculated by theta is equal to a tan into y gradient divided by x gradient. The next step is the non-maximum separation. In non-maximum separation, we scan the entire image and get rid of the pixels that might not be the part of an image. The final step that we apply here is thresholding. So the scanning edge detector goes to a further step and applies the thresholding to remove the weakest edges and to keep the strongest edges, so as we can easily detect the number plate. So this is how the theory or the plan of the scanning edge detection works. Now let's move towards the simulation and the implementation. So in simulation and implementation, we take our input image, that is original image, which is in RGB color, that is red, green, and blue. In order to provide less information to each pixel, we convert the RGB image to gray image. The next step is the pre-processing stage. That is, in pre-processing, we convert the grayscale image into blur image. The effect is the average of the rapid changes in the pixel intensity. So basically, it removes the outlier pixels that may be noise in the image, and it softens or smoothens the part of the image. So we are doing it using a filter called as bilateral filter, which is an edge preserving or a noise reducing smoothing filter for images. So after blurring the image, the next step that we apply is edge detection of the image. So we are using the tiny edge detector to detect the edges. After detecting the edges, we apply contours all over to the whole image, that is all over the image. When we apply contours, in order to process the region of interest, we reduce the number of contours that we are using. So we apply the contours on basically the 4 edges, and later on after applying, when we get the number of stripes is equal to 4, we form a bounding rectangle over the number plate, and our number plate is recognized. So this is the final implementation result of the number plate detection. So finally, here our number plate is detected and it is recognized using the optical character recognition. We can see that the characters are recognized and they are saved. The number plate of the vehicle is detected, recognized, and it is saved. So these are the references that we use to get the depth knowledge of the number plate detection and recognition. So these are the reference papers that we use, and so this is all about our project, and this is all about number plate detection and recognition using various image processing